Greetings and welcome. I'm Dr. Yogesh Malhotra, Yogi, founder of the New York State venture capital advisory firm, Global Risk Management Network, LLC. Our focus here today is to help you and your teams and enterprises to advance beyond historical data-driven backward AI for prediction of a bygone past to future outcomes-driven AIOps for enterprise agility. We create the digital future. You can too. Let's show you how. Many of you use Google, Bing, Copilot, ChatGPT, Perplexity, Grok AI, and dozens and hundreds of others top GenAI and search tools. You go to each individual site and often register and pay fees. Our quantum meta GenAI meta search saves you 99% time and 100% cost by providing integrated access to all of those without any registration or hidden fees. Now you can query, search, and mine all of those simultaneously using a single query for all from our websites. You can pick any of these: yogeshmalhotra.com, emailexchange.com, print.com, and c4icyber.com. You see these on this specific screen, and let me increase the full size of the screen so that you can see these completely. We offer you for free the latest and greatest, most advanced versions of these Meta GenAI, Meta Search, Quantum GenAI, Post-AI Quantum Networks, and Quantum Augmented Self-Adaptive Networks, QASANs. In addition, we share with you our 3 decades of cohesive R&D, which is the Post-AI Quantum Pioneer R&D. Elon Musk's Grok AI has analyzed last 30 years of AI quantum R&D for everyone and singled our R&D as singular Post-AI Quantum Pioneer, ahead of all, even ahead of Elon Musk. Given our trillions of dollars value added in advancing Silicon Valley, Wall Street, Pentagon, and worldwide organizations over the last 30 years plus. For the first time ever, we are presenting that 3 decades of cohesive R&D in this presentation, advancing upon our hundreds of papers, reports, presentations, article archives, and websites over the last 3 decades. It is the latest and greatest strategic execution blueprint which will help you advance beyond backward AI, which is 3 decades behind our future-oriented post-AI quantum focus as per Grok AI. It is based on our focus building quantum minds for quantum uncertainty in contrast to data-driven AI for the last 30 years. Our latest invention, which is quantum augmented self-adaptive network systems, or QASANs, offer you the blueprint for fast-tracking your AIOps strategy and execution geared to assure performance outcomes within unprecedented uncertainty and complexity. Now, with that introduction out of the way, let's focus on what we have on the plate today. We have mentioned that welcome to the transformative exploration, how the forward-thinking enterprises such as yourself can pivot from data-driven to outcomes-driven AIOps strategies, where success is measured not by data inputs, but by actual real business performance outcomes. And we enable through this the QASANs focus on anticipation of surprise, which has been our overriding focus since 1993, with focus not on inputs of data, but outcomes of business performance outcomes in terms of managing complexity and uncertainty. The organizations that thrive in the coming decades will be those that advance beyond prediction based on historical data to assure outcomes and thus transform uncertainty, which is considered often a threat and a major risk, into a strategic advantage using our quantum augmented self-adaptive systems. On the second screen, our focus is basically, as I mentioned earlier, instead of focus on data-driven, our focus has been on how to manage unprecedented uncertainty and complexity. Therefore, we thrive on uncertainty. And in this new business model of information age, going back to our interviews over 25 years ago in Fortune magazine, Inc. magazine, and CEO magazine interview, we pioneered this anticipation of surprise framework, which is underlying this most cohesive post-AI quantum R&D. On this specific screen, in addition to our specific Air Force Research Lab ventures, including Email Exchange and C4I Cyber, you see the world's first, foremost pioneering digital transformation network, which pioneered digital before the most people in the world knew about it. It's the Print.com website. And Fast Company magazine had called it at that particular point of time, if print doesn't have it, then you probably don't need it. Moving on to the next screen, this particular anticipation or surprise framework going back to 1993 can be articulated very simply in the following terms. The future is moving so quickly that you can't anticipate it. We have put a tremendous emphasis on quick response instead of planning. We will continue to be surprised, but we won't be surprised that we are surprised. We will anticipate the surprise. But that is the core thrust of where our work over the last 30 years is differentiated from the backward-looking AI models based on reinforcement learning and so forth, as we're going to observe. And based on our focus on the QASANs, using the latest developments in AI agent technology such as MCP and SP protocols, which we shall review later, in addition to related case studies, your enterprises can transcend the limitations of prediction based on historical data of the bygone past to focus on the future-driven outcome-assured operations. And this particular paradigm, instead of AI-driven automation, AI GenAI-LLM-driven automation, has been based on augmentation of human AI technologies for the last 3 decades. And currently, we focus on the augmentation of both AI and quantum computing technologies based on the fundamental premise of the quantum mind, which we shall introduce later. Following these specific distinguishing characteristics, your particular enterprises can focus on building competitive differentiation by focusing on building the future along with us, as we have been doing for the last 25 to 30 years, with true operational resistance in terms of being able to counter and manage not only dynamic adversity but also adversarial uncertainty. Following along to the next slide, what we have is a focus on the legacy systems and how that transition from legacy systems, the various operational challenges have advanced earlier. We pioneered what was called the business process reengineering innovation, having written one of the earliest papers used by worldwide organizations, as well as built the world's first resource website used by most pioneers in building and introducing the business process innovation and reengineering practices. Subsequently, we also pioneered what became known as knowledge management in terms of transitioning that focus on the radical redesign of business process workflows to re-everything focus, where we need to have agility based on phenomena which we now know as CI/CD, or continuous integration and continuous deployment. These particular specific precedents in terms of 25 years ago, we can see the reverberations and reflections of many of the phenomena which we are seeing again in the latest generation of AI technologies. We see that issues about investments in IT infrastructures and increasing skepticism about the relative performance gains, as well as the focus on the world of re-everything. That means there has been a traditional world where things need to be done cheaper, better, faster. The same phenomena, what we have called automation, but that automation with focus on replacing humans with machines, which we are seeing again after 25 to 30 years, has to be distinguished from streamlining of workflows and re-engineering, which was IT-intensive radical redesign, which was the focus about 30 years ago. And we need to consider it in terms of where things are changing all the time, in terms of high uncertainty and complexity. We cannot have a clean slate design, and how do we tackle those specific situations? There are a couple of points here which we want to distinguish in terms of the current emphasis on intelligence based on machine-driven paradigms. We had already distinguished the focus of agility based on augmentation, the organic systems, in contrast to the machine-based deterministic models, going back to our foundations on systems engineering and and systems theory. Specifically, the pioneer of systems engineering, Charles S. Churchman, has articulated and underscored that knowledge resides in the user and not in the collection of information. It is specifically how the user reacts to a collection of information that matters, not the specific information or data at hand. Additionally, the systems theorist Stafford Beer had also articulated knowledge and action being one. And we have seen the same systems theorists and systems pioneers basically articulating that knowledge and action are one, and these need to be considered in terms of bridging the knowing-doing gap, where our focus is on doing and actually executing in terms of delivering business performance outcomes, not merely just building knowledge and intelligence systems. So going back to our background in terms of having built the world's top-ranked digital website, the knowledge management website, the search engine, and our digital transformation network, Brint, we have been pioneering not only digital knowledge management, but also business model innovation. And as you observe from these contrasts, which we are showing on this screen here, we have indicated that the world of re-everything, where things change all the time in ways which cannot be predicted merely based on historical data, we have to hit the ground running, regardless of the fact that all our data which we have may not necessarily be the best indicator of future performance. As we know, particularly in the case of financial systems performance, the caveat that past performance is not a proxy or a correlate of the future performance necessarily. Therefore, in that particular context, we need to focus on the agility focus and primarily on the causal texture environments, where the external environment is shifting so massively, so tremendously in terms of the dynamic and adversarial uncertainty and complexity, that many e-business or digital enterprises are forced to re-architect all of part of the IT infrastructures, and they have to do it immediately. There is no time gap available. And going on to the next screen, where we distinguish again the contrast between the BPR, which we pioneered and led the world as the top resource and the R&D base, as well as the EE agility focus as the pioneer of digital innovation, knowledge management, and virtual organizations, having not only built the world's largest community of millions of worldwide users, 130,000 contributors, and 200 PhD experts and authors. We published the first books, journals, and papers, a couple of which you see here, on the focus being knowledge management, digital innovation, as well as the virtual organizations. And we have, going back to that very specific era, 25 to 30 years ago, very specifically observed and validated that people are central to our focus on handling uncertainty and complexity. Therefore, augmentation is our core focus going back. The IT human capital is critical for managing and evolving in the world of re-everything. And what we are observing, the focus on the right questions, the best answer, the test-driven models of AI, as we are seeing, they have already been obsoleted long ago. That these test-driven models based on archived historical data may be interesting from a theoretical academic perspective, but in the real world messes where most of these academic models are ripped to shreds, we need to be able to manage the unprecedented dynamic and uncertainty for which agility is critical, and the people are the primary drivers, as we are going to observe further. Now, this whole phenomenon is built on a focus in contrast to the earlier focus, mainstream focus of AI and the premise that AI is human-like, and the current focus on the neural networks as the primary drivers of transformers and the GenAI-LLMs and so forth. We have built the foundations based on the quantum mind. Where mind is different than brain, and brain is not just neural networks, because AIs, as we have researched, established, validated, and taught to undergrads and grads going back 20, 30 years ago, are of multiple types, including fuzzy logic, expert systems, as well as generic algorithms or evolutionary algorithms, founded on the fundamental premise of self-adaptive complex systems, which are a founding keystone of the evolution from the earliest knowledge management systems paradigm, where we have specifically articulated knowledge management being as the synergy of the smartest machines and the smartest humans to handle the most complex and uncertain environments. Therefore, going further, we observe that there are traditionally, based on our R&D, we have observed this contrast between the traditional works, areas of automation, where we can have the reinforcement learning models which are based on rewards, based on the historical data, and those rewards are premised based on the assumption that the future world is going to behave in the same way as the past world, and whatever worked best would work again. But this fundamental premise breaks down based on the observation about 25-30 years ago, when we were building our focus beyond the reinforcement learning at that given point of time, given the known caveats and the known limitations of the reinforcement learning paradigms and related algorithms. The focus we need to have is the post-AI quantum QASANs, which are focused on the anticipation of surprise, sense and respond, creative aberration and creative conflict, where the business model innovation for re-everything is the foundational premise. Therefore, going to the next slide here, we jump off from how the legacy infrastructure, the networks, the systems challenges were addressed, onto how our 30 years work has distinguished itself in terms of the human centered AI systems, the meaning-aware AI intelligence systems based on augmentation, and our latest focus on the post-AI quantum networks founded on the quantum generative AI, and as a pioneer of what is meta GenAI, meta search, which we have pioneered ahead of everyone else in the industry. And currently we observe even the biggest names which you have observed, including ChatGPT, Bing, and so forth, including Google, they are emulating what we have done earlier as a pioneer of merging the search and generative AI phenomena as the leader in this particular field. Now, these quantum AI networks, they are based on human augmented quantum intelligence. The focus is on human-centered, meaning-aware, outcomes-driven, self-adaptive, real-time execution and performance. Therefore, these systems are able to thrive on uncertainty in contrast to the legacy AI-LLM systems, which we consider, including the latest generation of the RLHF-based systems. They fumble in terms of their stature as static AI, as we have already observed in our prior discussions, presentations, and papers. Moving along, we are sharing here the 30-year post-AI quantum R&D, for which there is no comparison at all, as indicated by Grok AI, because we have built each of these foundations as pillars of what we are pioneering in terms of the post-AI quantum self-adaptive complex systems. We started the focus in early 90s on the causal texture and requisite variety of the environment coming from the systems theory, systems engineering backgrounds, and we started beyond reinforcement learning, given the known caveats of reinforcement learning, which we have shared massively in our papers, in our presentations, as well as in our social media dialogues. We also specifically distinguished the focus on the best practices development, when best practices become worst practices, and when those particular models, which were the primary leaders based on the rewards are hacked, and those specific models as well as enterprises are punished by rewards, which focus on the rewards rather than detection and correction of errors in real-time execution and performance. Therefore, our focus on external effectiveness is miles beyond the internal efficiency focus that has permeated most of the traditional knowledge management systems about 25-30 years ago, and the current systems based on the big data, big models, and big algorithms pervasive in the industry. Therefore, in this particular notion, the quantum minds, we are distinguishing from the AI thrust on human-like. We have argued and established that AI is not human-like. Specifically, AI is based on historical data, and had we as a human civilization, we've been waiting for AI to advance the human civilization when the civilization did not have something like what's fire or what's a wheel, and there were no pictures of fire or wheel before they were invented. We would have been still waiting for the AI to advance us. Although these specific products, including most others which have advanced the human civilization, are a function, are a derivative of the human imagination, intuition, insight, and creativity and ingenuity, much beyond the current mechanistic deterministic models of AI algorithms, which are miles behind these specific capabilities which are latent, programmed in the human systems. If we're going further, we focus on this particular flow of topics as we are going to be discussing these. And specifically, we have divided this presentation in three broad areas. The first particular section, we will focus on the paradigm shift to the outcomes-driven focus, in contrast to the historical data-driven. The challenge here is we might remain focusing on the data-driven, and despite reams of data and the explosion in data, where 60 to 70% data in every year would be new data related to all old data, we would be overwhelmed by it because the outcomes we are trying to chase, they have a chasm in with respect to this specific data. Therefore, unless we focus on the outcomes and are geared to evolving our models specifically related to those outcomes as well as the data, we would be far behind that. And we are seeing the industries catching up, as we're going to see in the next slide when we discuss the data tsunami, why more isn't better. Therefore, going on to the next slide, what we find here is the preface to our section 1. We focus on a recent this observation of a historical milestone, 100 years of quantum mechanics, and we are looking at this particular LinkedIn post from the CERN organization discussing in the year 1925, about 100 years ago, when Werner Heisenberg had discussed with Wolfgang Pauli and with Enrico Fermi. He was trying to liberate the physics from the status quo, the legacy models which were not truly depictive of reality. And he said basically that how he was trying to replace it with something suitable. Our QASANs and post-AI quantum networks, 100 years later than that specific point of time, are liberating the backward AI from the past by orienting it towards the future and enabling it to do so with the quantum augmentation focus. And the Grok AI, having analyzed the last 30 years of research, which we have built on the prior 40 years research, has already indicated that our particular work, our vision of QASANs is the vision for the next 25 to 30 years. Therefore, what we have here is a vision from 1993 to 2050, indicating a world of quantum augmented adaptive networks where quantum uncertainty empowers human adaptability, reshaping economies, societies, and security with a resilience unmatched by today's static AI. Moving along to the next slide, what we have here is a recent observation which is a refreshing contrast from many other observers, including the NVIDIA CEO and others, and who have been observing that we will not need any coders and programmers anymore. Their specific focus is based on a legacy notion of coding and programming, where coding and programming is just deterministic modeling, which is the machine-based deterministic routine, procedural, structured specification of logic in terms of code. But if we truly understand how innovation occurs and the role of true human ingenuity in that, we can immediately understand why Bill Gates' recent observation in the last week or so is so critical, that AI won't replace programmers, not now, not even in 100 years. Because the notion of programming has evolved. It is not the same as even 5 years ago. What we are able to do now with GenAI-LLM programming and so forth has enabled us to do in terms of programming the natural language what was not even feasible a couple of years ago. Therefore, our QASANs, the post-AI quantum networks, are focused not only in terms of rethinking AIOps from traditional data-driven historical backward AI to future-driven augmented quantum AI, but also rethinking what is coding and programming, which is a very critical point in terms of understanding how we need to evolve and advance the related educational paradigms and practices in terms of programming and coding in our various institutions and schools, as well as also help our silo-focused various organizations break through the silos and understand the coding and programming in new terms from broader systems and networks overarching perspectives. So coding now isn't just about typing lines, it's about deep thinking, solving hard problems, and being imaginative. This is very much congruent to what we have been doing for last 30 years, and no algorithm can match human ingenuity, not even the master algorithm. Our observation is based on the contrast and the advances made beyond the keystroke level model, which was pioneered at Carnegie Mellon, where the input keystrokes are less and less correlated to the outcomes in terms of what is feasible and possible, in contrast to what is probabilistically deterministic in terms of what may be only done. Going to the next slide. Our focus here, as Bill Gates has pointed us basically earlier, as role models to the world, discussing our work going back to 1990s as the world's top digital site search engine social network, introducing to his corporate network on his website and his best-selling book. And it seems that Bill has again reviewed some of the stuff we have been pioneering in terms of QASANs and quantum minds for the last couple of years, and his latest perspective seems to be very much aligned with the direction where we see coding and programming evolving. The QASANs and post-AI quantum augmented AI is not only about revolutionizing AI, but also rethinking coding. And as the first foremost digital network, Bring.com, Google had come to us before its IPO in 2004 to build its global digital footprint. 20 years later, we are pioneering Meta GenAI, Meta Search, leading the whole pack, including the world's latest, greatest billion-trillion-dollar companies who are playing catch-up to us. And we have already pioneered QASANs, which, as per Grok AI, represents the future of augmented human AI intelligence as well as AI quantum networks. And based on the focus of our Air Force Research Lab ventures, also the New York State Idea Award winner, New York State Capitol, for which we have been guiding leading practices for the New York State Governor conferences, advancing the AML quant, cyber crypto quantum over the last 10 years or so. Therefore, what is important on this slide, on the left side are some very key URLs and resources which you can use to dig deeper and build on the work which we have been doing, on which the world has already been building up for the last 30 years in terms of our contributions, which have enabled the billion and trillion-dollar companies further to create the digital future with us. If the question here, what we ask is, going back about 8-10 years, is why search when you can go beyond search, like in Google search. Even now Google search GenAI, you can go to multiple GenAIs and search integration, saving your time by 90-99% and costs by 100% using our tools which are freely available. And these are not about just search or intelligence. These are about what we call no build monetize ventures, which are rethinking, redefining digital life, learning, work, as we have known over the last 30 years as pioneers and leaders of defining what became the digital life learning work and the knowledge economy-based life learning work. And now we are focused on the post-AI quantum life learning work with the next generation of technologies which are already becoming feasible. Therefore, in a specific way. We are building the future of human civilization, and we invite all of you to use these tools which are made available to everyone. Now, these technologies, the prior version of some of these, which we build as MVP for some of the projects, such as invitations based from Pentagon, Air Force, and so forth. We built MVPs, and some of these technologies built on our prior MVPs are being licensed for $30 million per site per license, as we came to know. But we have decided not only to offer the latest and greatest generative AI and the multi-gen AI meta search, as well as the latest post-quantum networks for free to everyone, because our contributions are not in terms of how many trillions we accumulate, but trillions that we contribute to the world, and how many trillion-dollar companies are able to further advance, benefit the world by leveraging our specific practices, technologies, networks, and niches. Going on to the next step. Now, this is a framework, which is a 30 years framework, which we are showing here, and we are articulating some of the work which we have been doing going back about 30 plus years. And we have written specific research papers advancing beyond the reinforcement learning for over 30 years or so, pioneering the real-time enterprise models around 20 years ago, which underlies today's AI, latest AI models like retrieval augmented generation. And we have already advanced beyond that over the recent few years as building quantum minds for quantum uncertainty, with the central focus on human mind as the quantum mind, where our research was founded 30 years ago, in contrast to the data-driven backward AI. Therefore, the focus right now is on the quantum uncertainty, which has been the overdriving focus of most of our work, in terms of synthesizing the dynamic adversity, this uncertainty, as well as the quantum adversarial uncertainty for the last 30 years as pioneers of not only AI but also cyber resilience technologies, and the integration thereof of AI, ML, quant, cyber, crypto, quantum technologies, for which our programs, our courses, and our invited research presentations have led the top executives at programs like MIT, as well as the Wall Street quants, building the next generation practices in multiple conferences at the Princeton University. Moving along, now we jump on to the first section, as I mentioned earlier, the data tsunami. And the question here is, we have seen the whole thrust since we had big computing and big bandwidth, and everyone, very surprisingly or not surprisingly, jumped onto big data or big computing. And the problem here is, big is expensive. But since everything was available, they said, why not throw everything like the whole spaghetti at the wall and see what sticks. That big data was very fashionable a few years ago. Then we saw that big data is not being discussed, has lost its traction, and everyone started talking about the small data. And more lately, we have focused on the recent year or few years, is the focus on right data. Similarly, we have seen the same focus on the trillion parameters of what you have, the biggest models. And now we have seen the focus shift to the small models. And we are also observing that at some point, it will come to one's cognizance the right models are what matters. It depends on what works. Since it is not one model, but a combination of various capabilities which you can harness across the diversity of models which are available across the various kinds of technologies. And you've seen the same kind of transition from the hype about the master algorithm, the big algorithm, the small algorithm, the right algorithm. The right was right all along, but we have to go around this song and dance. Therefore, small is beautiful as far as expense is concerned. Expense is not income. More expense is not more income. And we have seen this simple realization, which is very common sense based realization. Cheaper, better, faster was the idea. The point is, we are getting cheaper, better, faster, but the marginal cost of that cheaper, better is much more than cheaper, better, or faster. And you've seen that particular realization with the $1 trillion wipe out of the financial markets as the deep sea. The point simply here, what we are trying to drive home, it doesn't matter what technologies you have. It doesn't matter what models are going to have. What matters is what kind of outcomes you are able to achieve. And your creativity and ingenuity lies in how you can achieve the same outcomes at a lower price compared to anyone else out there. Therefore, that is what we have in front of us, the creativity, imagination, insight, and intuition. Given that most of the models are pretty much commodities, everyone has access to those. Therefore, how we actually deploy, use, and create the most outstanding performance outcomes, that is our measure of success. In contrast to the prior focus, where how much data or how many trillions you spend on data inputs, inputs are not outcomes. Outcomes matter, inputs do not. And the lesser dollars you spend to make more dollars, the smarter you are. Going on to the next slide, we are focusing on the backward AI as we have been driving home this particular point that since most of this AI based on RL has been based on historical data, it is like you're driving a car, but you are not looking through the windscreen. Your windscreen, front windscreen is blocked. Instead, you have got a rear view mirror. And you try to drive your car to the future, to the front, while looking in the rear view mirror. How long can you drive without really crashing your car? That's the current status of all AI, including the self-driving cars, where Grok AI's analysis indicated that if the smartest people driving the self-driving cars, innovation would have paid attention to our work, which we have shared in this particular slide deck, they could have saved likely hundreds of billions of dollars of misinvestments, where we can use the human smarts in combination with the machine smarts in the most optimal manner, instead of trying to automate where automation may not even be necessary or feasible or not reliable. So this is where we are trying to focus on uncertainty complexity, and we are trying to advance beyond the correlation focused data mining to the causality based real science modeling based on which our work has progressed. And we are trying to bring back AI, which has built on data mining, which was in fact data mining based on correlation, to focus on real causality as the pioneers of focus on research on causality, uncertainty, and complexity for last 30 years. And in that context, many of our invited presentations at places like Princeton focus on these phenomena of dynamic uncertainty and adversarial uncertainty, and we recommend you to actually look through them to understand the various AI machine learning controls and risk management and so forth, and how these particular challenges of historical data, of correlation, can be overcome with our focus on the future-driven AI augmentation. The next slide goes further in detailing the issues with the backward AI, which are as pervasive in the current GenAI-LLMs, given the focus on past patterns, the blind spots which are there, which we are seeing often in self-driving, and in areas like even the weather-based models, the financial markets, even the lunar lander models, where we are seeing the space moon rover lander landing issues. These are specifically the RL-based problems, but given that future is not equal to past, and if you are receiving rewards and the world changes in ways which are not predictable based on past data, that's when best practices become worst practices, and we need to rethink what we are doing, rethink the rewards in the context of what's happening now, not what was happening in the earlier past. Now these foundations, as we observe, we have built these foundations over 20 to 25 years ago. Our real-time enterprise model published in the Journal of Knowledge Management had specifically articulated how the smartest companies can shift or should shift, particularly in areas where they are trying to move beyond automation. A simple automation, which is interesting, but is not the specific wheelhouse for the biggest opportunities and threats. Those lie in areas where the radical discontinuous change, where we pioneered the research earlier, the dynamic uncertainty, the adversarial uncertainty and quantum uncertainty, where the outcomes need to be rethought, redefined. Therefore, the lower picture which you observe here is where we see the evolution of RAG or retrieval augmented generation as bridging the disconnect between the top technology push and the lower statistical model. It was an interesting step, but we anticipate it to be advanced further with the increasing understanding and application of quantum human capabilities in addition to the latest quantum technological computing capabilities, which will help us advance beyond the historical correlation-based focus, with focus greater on meaning-aware human context and values, therefore overcoming many of the AI issues of the AI bias based on historical data, and focusing on measuring success not based on how much data you process, but how robust outcomes are achieved and how comparatively they are achieved. We move on to the next slide, and again, this is our specific framework, just to remind us that this particular one slide captures the 30 years framework, and we are trying to build on that. Going on to our table of contents, moving on, the next section focuses beyond the paradigm shift to outcomes, to how these outcomes can be enabled using quantum augmented self-adaptive networks, our invention of QASANs, building on our paradigm of focus on quantum minds for quantum uncertainty. For instance, in the Princeton University presentations, we had specifically observed that those accustomed to observing what they can see through their eyes for in terms of risks and uncertainties for the pre-web era would be challenged to see what they cannot see with their eyes, but they will have to see with their minds. And that's where the focus is on quantum minds, which are able to see in terms of ingenuity, imagination, creativity, insight, and so forth, the specific shifts in trends which are beyond the capabilities or the sense making or the sensors of AI systems at this particular point of time. And in that particular context, we observe some specific technological developments. This is an example, and there are many other such examples, but the model context protocol, the MCP, and agent combination protocol, as we observe, are specific interesting developments in that specific direction. And moving along, we are observing also risk and reward are kind of inverse of each other. The better you manage risk in the most uncertain, the most volatile environments, the greater your rewards are anticipated to be. Therefore, in terms of our focus as the world-leading global risk management network, LLC, our risk management frameworks are and have been leading the industry by 2 to 3 decades based on our published work. And here is one specific slide based on our latest analysis, which clearly contrasts how the NIST ISO standards need to catch up with our focus on the dynamic, adaptive, quantum augmented focus on real-time resilience in terms of managing and preempting adversarial dynamic quantum uncertainty and complexity, enabled by self-learning and feed-forward event-driven architectures. We have discussed specific applications in terms of the most advanced battle management systems, pioneering the next generation ABMS2 based on joint all-domain command and control, advancing it to adversarial command and control as a counter-adversarial command control. And similarly, we've advanced the Wall Street AIML quantum systems, not in terms of model risk management, but having pioneered the model risk arbitrage with a focus on the black hat, where we can advance the next generation hedge fund strategies and so on. Now, what we are pioneering is in terms of sustainable performance of agility and resilience. So we're going to be moving pretty quickly through the next set of slides here. QASANs, again, we discussed, we are looking at beyond backward driven past probabilities to future-oriented possibilities. And again, we've discussed forward-oriented processing, human-centered design, the self-adaptive structures, and the quantum architectures. Moving along, On the next slide, we are focused on three powerful elements. These are the key three elements. First is the augmentation. It is not automation. Automation is great. We're not saying it's not good, but its benefits in terms of investments are not as great. The threats which we need to encounter cannot be encountered with automation alone. We need augmentation in terms of emulating the human intuition and sense making, which are clearly contrasted from the machine-based data processing for the last 30 years or so. Therefore, augmentation of human-machine quantum computing AI and the human-centered quantum computing AI and meaning-aware quantum computing AI. In addition to the self-adaptive focus, which has been the underlying focus with the latest shelf life, which we have built for the sustainability of agility and resilience, starting from the digital to knowledge to AI to post-AI quantum economics. And the requisite variety and interpreting flexibility are the two key phenomena which you will find discussed in many other papers. Moving along, we have discussed QASANs in terms of managing quantum uncertainty with quantum minds, and the foundations of some of these notions are given here in terms of the philosophy of knowledge, in terms some of which we discussed earlier. And there's a conference paper on inquiring organizations which distinguish the Kantian Hegelian from Leibnizian and Lockean focus of technologies in terms of the highly uncertain environments where the challenge is not finding the right answers to the given questions, but understanding what are the right big challenges and questions. Therefore, in fact, looking at not only the millions of complementary solutions in terms of quantum hyperspherical models advancing beyond the hyperplanar models, but also in terms of the devil's advocate with contradicting and challenging. Therefore, in this notion, we need to be distinguishing human mind based on its meaning-making capacity and capability in the most uncertain environments in terms of the integration of affect, cognition, action, which is missing so far in most models, which is the foundation of most sense-making versus data processing, as we have already observed and validated in prior research. So going further, we have noted some of the papers here, going back 25, 30 years, which can be relevant of interest in advancing some of these models. Going further, what we observe here is the MCP and ACP. Primarily, these are some capabilities where you can have these various agents interacting with each other across various domains, across with various tools and services. Basically, we see these advancements encompassing not only the current generation of AI and various AI generation technologies, but also in terms of the quantum computing and AI quantum nexus as we progress further. The next slide is basically recapping what we have, the framework, moving along to the final section, where we are focused on strategic roadmap to outcome-driven AIOps. And what are the implementation challenges and how we can manage the risk of some of these challenges. In this particular focus, what we have is, again, as you observe, we need to start at the baseline where the current state is, and we need to have a human-centered focus, the self-adaptive, human-augmented, and then scale and optimize. The key points which are focused is we need to focus on the outcomes and meaning-aware capacities for real-time learning, adaptation, and human anticipatory capabilities augmented by quantum computing capabilities as they evolve further. And in many of these contexts, our focus on smart minds using smart tools. This is something which I observed across various interviews, papers, and conferences. Beyond the focus on AI sensor limitations of hyperplanar modeling, again, we are talking about focusing on, some people talk in geometrical mathematical topologies, in mathematical modeling, such as in vector-based modeling and so forth. We are recommending advancing beyond the quantum, from the classical computing to the quantum continuous time-space states of physically, mathematical, dynamic modeling, and non-normal, statistically non-normal states. Moving along further, we have again the same particular framework. We discussed in a bit more detail, baseline to the transformation to piloting and so forth. But what we are offering you here is why not try some of these particular frameworks and questions, teasing them out. We have given you specific examples in these hands-on tools, the meta GenAI, meta search, the quantum GenAI technologies, using the AI square or AI appreciative inquiry, which we would recommend you to use and apply as you go along. Building along on this, we are going on to the next slide. Again, we have the implementation challenges starting from the focus on integration of not only the human but also the classical to modern quantum and AI quantum technologies, and the focus on ethical frameworks which are founded based on the human values and augmentation. And the human-centered design is critical for that. And interdisciplinary collaboration across the socio-technical and computing sciences is critical for that, as we have observed earlier. Therefore, we do observe, in addition to the fault tolerance and error correction issues, where we have seen some recent advancements, which you will find discussed in the related paper, which you can download. Some of these MCP, ACP capabilities advancing us further in this area. In the ethical frameworks, again, the human augmentation, quantum minds, smart minds, these things are relevant. And human-centered design, again, more of the same. Are these frameworks in the bigger picture are also relevant here? Moving on to interdisciplinary collaboration, which we have discussed earlier. Again, the same focus on the bigger frameworks. We would recommend many of these collaborators to understand the notions of quantum minds and quantum uncertainty based on adversarial dynamic uncertainty and time-space complexity as the phenomena which needs to be managed by transitioning beyond the driven historical this backward AI to future-oriented post-AI quantum AI, which can be. Now, we would like you to try hands-on to bridge the knowing-doing gap, some of these specific human-in-the-loop, the QKD issues and so forth, which are discussed here. Talking about the same, there are a number of cases where we see the potential applications of QASANs. Moving along, we've discussed a recent case study which came out and was widely discussed in practice, where the medical superintelligence has advanced beyond the traditional test-taking capabilities to handling the more reasoning capabilities in the complex messes as we have been trying to address over the last 35 years or so. And we have offered you specific these links here and specific reports where you can see how the application of QASANs, which you have pioneered, can address these medical superintelligence beyond even the latest state of art. You can click on the slides here where you can go to the hyperlinks, or you can type these links directly to go and actually try these hands-on. We're showing you the specific contrast between the static, the old legacy, and the meaning where augmentation, where our contributions are, and what are key pillars as discussed in terms of copilot and so on. And moving along, what we are discussing here again is not only applicable to these industries, but also to autonomous networks, the intent-based networks, which is the latest topic being discussed there, where you, based on the intent, these specific outcomes will be defined, and we are seeing a progression beyond what used to be data-driven to outcomes-driven to intent-based networks, which will finally connect to outcomes-driven focus where we have been propagating and encouraging everyone to involve. Some examples of what kind of outcomes we can see, outcomes-based measurements and metrics. These are just exemplary. These are what we might possibly expect. The numbers may change, but the kind of measurements, the kind of outcomes which may be relevant, moving beyond the data-driven outcomes of trillions of parameters and how much trillions of dollars is spent in these are something of interest. Moving along to the next slide, similarly, the measurement frameworks in terms of what are the outcomes, costs, productivity, service availability, security incidents, and so forth, and the success factors. I think these are again the value addition in terms of the business outcomes, not the inputs or the processing, like the data inputs or insights and so forth. Therefore, finally, we are near the end of our presentation, and we will be delighted to take any questions once we conclude. What we have discussed in terms of the takeaways for this particular session is primarily two things here. Based on the trillions of value added with our technologies that are pioneer digital, knowledge, AI, and Now, post-AI quantum technologies applied by the world-leading Silicon Valley, Wall Street, Pentagon firms, US world governments, and worldwide institutions and organizations, many of which you might have already heard of or known of as the pioneers and world leaders. We are offering you those technologies in the latest, greatest shape. The MVPs for the earlier generation, as we said earlier, are being licensed for were being licensed for purpose just a few years ago. But we have decided to keep these technologies and build them further up, augmenting these capabilities with the latest GenAI, the meta GenAI, meta search, the post-AI quantum networks, quantum GenAI, and so forth, to keep it available free to everyone so that all of you can benefit with us. We succeed in the success of our clients, of the users, the millions of users earlier, and the billion-dollar to trillion-dollar companies creating trillion-dollar values out there in addition to the US and world governments. So we would like to see how we can contribute further in advancing you, because your success is our success. Going further, again, a final look at the framework. I mentioned the Goldman Sachs, the Standard Institute. These were kind of two foundations going back to the early 90s in terms of their, while doing my PhD research. A lot of our focus was built into certain complex systems, as well as the anticipation of surprise frameworks, which were the foundations of our work, some of which we have shared here. Across the presentation, I've given you ample references. I've given you these logos. The logos are meant to represent the specific presentations, the papers and the lectures and courses that you have built, which are freely accessible to you online in my publications, presentations list, or by LinkedIn articles and so forth, which you can download and follow up as needed in the specific context, as I've indicated in this presentation. If we're going on further, again, the takeaways are for achieving this anticipation of surprise, where we will continue to be surprised, but we won't be surprised that we are surprised. We will anticipate the surprise. Therefore, in these specific environments, the high levels of uncertainty and complexity will be leveraged, adopted, applied, cherished, embraced by the organizations, which will not only thrive on uncertainty, but help the human civilization thrive on uncertainty as we advance further into the most highly unprecedented uncertainty environments. Going further, this is where we started, and note that if Brent does not have it, then you probably don't need it, and obsolete what you know before others obsolete it. This is how you make sure you are always ahead of any AI, and that is also the focus of the human quantum mind and anticipation of surprise model, which has been tested in actual physical landscapes very intensively to inform the notion of mathematical landscapes, is now ready for advanced modeling and application across beyond the physical landscapes to much larger cyber and space-based systems, and we are looking forward to future opportunities of making additional contributions in that regard. Therefore, as we progress further, it has been a pleasure and privilege over the last hour or so to have contributed to this discussion, and if we could be of any help to you, feel free to contact us. Our information has been shared with you, and you can, through these particular websites, which are post-AI quantum networks /bio.html, which are his own portfolio. You are welcome to contact us, and it will be a pleasure and privilege to be of service to you, to help you advance further. Thank you.